Okay, the first problem we are going to solve in the chapter 7.3 solving radical equations is the cube root of x minus 2 equals 0. Although it doesn't look very pretty, you just simply add 2 to both sides. You end up with the cube root of x equaling 2. To get rid of a cube root, you cube it. Just like when you get rid of a square root, you square it. So we have to cube both sides. Cube root of x cubed is just simply x. 2 cubed is 8. Now to check it, simply substitute in the x value of 8. Let's go back and circle this. And so we're going to have the cube root of 8 minus 2 equals 0. On your calculator, you're going to press the math key. Number 4 will give you a cube root. You put in 8. And when you hit your enter key, you'll end up with 2. So 2 minus 2 equals 0. 2 minus 2 is, in fact, 0, so the problem checks out. Okay, we're going to go ahead and try this next one, number 1, which is from page 365. Okay, so you should have added 4 to both sides. Square root of x equals 4. You would have taken the square root of this, you would squared the square root to isolate the variable. So you would have ended up with x equaling 16. And then to check that, you simply put in the square root of 16 minus 4 equals 0. Square root of 16 is 4 minus 4 equals 0. 0 equals 0. So it checks out. Let's go ahead now and try number 2. And this is still page 365 checkpoint. And this is another cube root. So you take the cube root of x plus 3 equals 0. Go ahead and try the problem on your own, and then turn the recording back on to see how you did. So on the cube root of x plus 3 equals 0, the first step is to subtract 3 from both sides. Leaves you with the cube root of x equaling negative 3. To get rid of, or to isolate to get rid of the cube root, or to isolate the x, you have to cube both sides. So the cube root of x cubed is x. The cube root of negative 3 is negative 3 times negative 3 times negative 3, which is negative 27. To check this, you simply substitute your negative 27 back into the x position. If you take the cube root of x, meaning what multiplied together 3 times will give you negative 27, you get negative 3, plus 3 equals 0. Negative 3 plus 3 is 0, so 0 equals 0, so the problem checks out. Okay, so the first step you're going to do is to add 1 to both sides, which gives you 3 square root of x times the square root of x plus 4. 1 and negative 1 is nothing, equaling 8 plus 1, which is 9. Your next step is to divide both sides by 3, and so you're left with square root of x plus 4 equaling 3. Okay, you're squaring both sides, so you end up with the square root of x plus 4 squared is x plus 4. 3 squared is 9. Subtract 4 from both sides, and you end up with x equaling 5. Now we're going to substitute it back into the original equation for our check. And that's going to be 3 times the square root of 5, because x is 5. 5 plus 4 minus 1 equals 8. Go ahead and go through that. You should end up with them equaling one another, both sides equaling one another. When you check this, you plug in for your x, you plug in the value of 5. So you have 3 times the square root of 5 plus 4 minus 1 equals 8. The radical symbol comes first in order of operations. 5 plus 4 is 9. So you have 3 times the square root of 9 minus 1 equaling 8. In order of operations, radicals come before multiplication or subtraction. So square root of 9 is 3. 3 times 3 minus 1. Again, order of operations, 3 times 3 is before subtraction. So 9 minus 1 does equal 8. 8 is equal to 8. So the x equals 5 is correct. Go ahead and write down this next problem. The square root of 2x minus the square root of x plus 1 equals 0. In this problem, the square root of 2x minus the square root of x plus 1 equaling 0, you have 2 radical symbols. The easiest way to be able to eliminate the radical symbols and then solve it is to move this square root of x plus 1 to the other side. So we're going to add the square root of x plus 1 to both sides. Since this is 0, this just becomes the square root of x plus 1. And then on this became 0. And then on this side, we have the square root of 2x. Now, as we recall from earlier, in order to get rid of a radical symbol, we take the square of it. If we square one side, we have to square the other. Now you can see why this is working so well. Square root of 2x squared is 2x. Square root of x plus 1 squared is x plus 1. And the problem is quite simple to solve. Okay, we're going to subtract x from both sides, which leaves us with 2x minus x is x. X and negative x is nothing, so you're left with x equaling 1. Now we're going to go ahead and do the check. So we simply substitute the 1 back in. So it's the square root of 2 times 1 minus square root of 1 plus 1 equaling 0. 2 times 1 is underneath the radical symbol, so we have to do that first. So 2 times 1 is 2, square root of 2, minus 1 plus 1 is also under the radical symbol. It has to be done first. So 1 plus 1 is 2, so square root of 2. Since these are identical, square root of 2 and square root of 2, and you're subtracting them, you're going to end up with 0 equaling 0. That means that x equals 1 checks out. Okay, so the first step is to add 2 to both sides, which negative 2 and 2 is nothing, so it equals 5, and then you have the square root of x plus 1 equaling 5. To isolate the variable, you first have to get rid of the radical symbol by squaring. 5 squared equals 25. Square root of x plus 1 squared is x plus 1. Then you subtract 1 from both sides. 1 and negative 1 is nothing. You're left with x on the left. 25 and 1 is 24. Now we're going to go ahead and substitute the 24 back into the problem to check it. So we're going to have the square root of 24 plus 1 underneath the radical symbol minus 2 equaling 3. 24 plus 1 is under the radical symbol, so you do that first. It gives you 25. Square root of 25 minus 2 equals 3. Square root of 25 is 5 minus 2 equals 3, and 5 minus 2 is 3, so 3 equals 3, so 24 is the correct solution. The next problem that you're going to do is number 4 from checkpoint, the checkpoint on page 366. Number 4 is 2 times the square root of x equals the square root of x plus 3. Now, whenever you have a radical on both sides, you will get rid of that radical by squaring. But before you do that, you have to do something with the 2 times the square root of x. Go ahead and see what you can come up with, and then we'll check it. The first step before you can get rid of the radical symbols is to divide by 2 on both sides. And so you end up with this 2 divided by 2 becoming 1. And you're left with the square root of x equaling the square root of x plus 3 over 2. To get rid of the radical symbols, you square both sides, so you have the square root of x squared, which is going to give you x. Then you're going to square this side, the square root of x plus 3 over 2, and you're going to square both the numerator, the square root of x plus 3, and the denominator 2. You're using the power of a quotient property when you do that. So when you square, the square root of x squared is x. When you square x plus 3, square root of x plus 3 squared, you get x plus 3. And when you square 2 squared, you get 4. It would be easier if you don't want to use the multiplication property of equality. If you just put a 1 underneath the x, you now create a proportion so you can use cross products. It's up to you. It's not mandatory that you use cross products, but a lot of students do better with cross products. And then continue on your way solving, and you should be able to solve. When you use cross products, it's x times 4, which is 4x, and 1 times x plus 3, which is x plus 3. Okay, so we're going to now subtract x from both sides. 4x minus x is going to be 3x equaling 3. And you are going to divide both sides by 3 using the division property of equality, and x is going to equal 1. And we're going to go ahead and do our check. Make sure we're right. And we're going to substitute this x into the original problem. So it's going to be 2 times the square root of 1 equaling the square root of 1 plus 3. Go ahead and solve that. They should come out to be equal. Okay, when you check, our x was 1, you substitute that 1 back into the original problem, so it's going to be 2 times the square root of 1 equaling the square root of x plus 3, or 1 plus 3. On the left side, you've got the square root of 1, which is 1, so 2 times 1, which is 2. On the right side, you have the square root of 1 plus 3. You have to do what's inside the radical first. 1 plus 3 is 4. Square root of 4 is 2. 2 does equal 2, so x equals 1 is the correct answer. Our final problem is going to be number 5, the square root of 3x minus 2 minus the square root of x equals 0. Whenever you have two radicals, the simplest way to solve this is to get a radical on both sides so that you can square both sides. So go ahead and see if you can do that. Okay, when you have the square root of 3x minus 2 minus the square root of x equals 0, again, the fastest thing to do is just to get the radicals, one of the radicals on the other side. So we're going to add the square root of x to both sides. And then you're going to end up with negative square root of x and positive square root of x being nothing. So you're left with the square root of 3x minus 2. And then 0, and the square root of x is the square root of x. Now you can multiply both sides by, you can square both sides, which will get rid of the radical symbols. That's a property of equality. So we take the square root of 3x minus 2 squared, and we get 3x minus 2. We take the square root of x squared, and we get x. There's a couple ways you can do this. If you don't like working with negative exponents, you can move the x, then move the 2. But I would just subtract 3x from both sides to get the x's collected on one side. So we have negative 2 equaling negative 2x. But again, if you don't like working with negatives, then it would be fine to collect the x's in 2 steps. We're going to divide both sides by negative 2. Negative 2x divided by negative 2 is x. Negative 2 divided by negative 2 is going to be 1. So x equals 1. Now we're going to check this. We substitute in a 1. So we're going to go into the original equation. So square root of 3 times 1 minus 2 minus the square root of 1 equals 0. And square root of 1 is 1. And then we just can do this mentally. 3 times 1 is 3, minus 2 is 1. So this is the square root of 1 minus 1. And then the square root of 1 is 1 minus 1. And 1 minus 1 does equal 0. 0 equals 0. Therefore, x does equal 1. You figured out that that was correct. This concludes solving radical equations.